Chapter 5 Conics. So under the topic of Conics, we will have 5 subtopics, starting with 5.1, 5.2 circles, 5.3 ellipse, 5.4 parabolas, and 5.5 hyperbolas. So under 5.1, we are going to learn Introduction to Conic section. So what is conics? Conic section, or we so-called conics, are curves obtained as the intersection of a right circular cone and a plane. So you imagine two planes first. This is plane 1, this is plane 2. Okay? So when they intersect each other, right, you will obtain a line. The intersection between two planes is a line. So this is the same method in right circular cone and a plane. So when you have a right circular cone and when you have a plane, when these two plane and cone intersect each other, it will form a curve. And this curve is known as conic section. Understand?
Yes.
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 Okay, so now we'll move on to the type of conics. So when different plane intersects the conic at different angle, we will get different conics. So let's say you have a right circular cone and the plane intersect the cone is at horizontal. Means there is no angle between the plane and the base. Okay? So when this plane intersect this cone, we will obtain a curve or which is known as circle. Okay? When you see it from top view, you will see a perfect circle. Okay? So next one. When the plane intersects the cone at an angle with the axis less than angle theta, the intersection is an ellipse. So now let me explain what is this angle theta here means by. So when you side view this cone, you will obtain a triangle. Okay? This is everyone knows, right? So this angle is represented by the angle between the slanted height and the base, and we name this angle as theta. So when you have a plane when you see from the side view, you will see only one line. Okay? And when this line intersect, this line makes the angle with the base having angle theta 2, where theta 2 is less than theta 1. So when theta 2 is less than theta 1, like in the slide, you will obtain a curve which is known as ellipse. Understand?
Yes.
Next one. So when you have a plane having an angle with the base of theta, the same angle with this theta. Okay? So see in the slide, we're having this plane intersecting the cone, we will obtain a parabola. And the last one, when we have an angle, when we have a plane having an angle greater than theta when it is measured to the base, means like this. Name is theta 3 larger than theta 1. Then this curve is called hyperbola. Okay? Okay, so now we will move on to 5.2 circles. Under circles, we will also learn the equation of the circles. Okay, so now let's define circle first. A circle is a set of points in a plane that are equidistant from a fixed point. Okay, and this midpoint is called the center, whereas this fixed distance is called radius. So now we imagine the points and the lines first. So we start with a fixed point, this one. Okay, you can see this point, right? Okay, so having this point, you plot another point and you measure the distance and you label as r. So now our r here is the fixed distance. Okay, moving on, we plot another point also having the distance r from this fixed point, and maybe can obtain a point around here. Another point we also can make like this one, also having the same distance r. Okay, after you have, let's say you have the 3 points, right? Then you join all the 3 points into one curve, not straight line, curve, and you will obtain this circle. Okay, so a circle is a locus that having all the points which has a distance r from this fixed point, And this fixed point is called center, whereas the distance r is called radius. Understand?
Yes.
Okay, very good. Now we move on to the equation of the circle. So after we have defined what is the circle, now we can move on to find out the general equation of these circles. So before we start working out the general equation of the circle, we will examine the sketching here first. Okay? This is the xy coordinate plane and having a curve around here, which is called circle. And this circle has a fixed point in the center, labeled as C, having coordinates AB. And we will take any other point on the circle. Let's say we take this point P and having coordinate XY. So when we want to start to work out the general equation of the circle, first thing we have to remember the formula to find the distance between 2 points. So let's say we have a 2 point x2 and x1, x1, y1 and x2, y2. So let this point be x1, y1, let this point be x2, y2. So to find the distance between these 2 points, now we use the formula d equals to x2 minus x1 squared plus y2 minus y1 squared, which you already learned this formula in form 2, right? So then squaring both sides, we will get d squared equals to x2 minus x1 squared plus y2 minus y1 squared. Okay, understand? Okay. Now observe from the diagram again. We have the radius for this line, right? And this line we call it CP. And this line we denote it as a variable r first. So putting all the points into this equation, let P be x1, y1 and CAB be point x2, y2. So we will sub this into the equation and we have CP equals to R or equals to the distance lah. So R squared equals to x minus a squared plus y minus b squared. And this is our general equation for the circle. Okay, in special case where the center of the circle is the origin, where AB equals to 0, 0. Now, we try to sum in AB as 0, 0. Okay, so R squared we meant to copy it down, and x minus 0 equals to
X.
so we have x squared. Y equals to 0, we have
Y squared.
y squared. Very good. So this is a general equation of a circle for where its center is 0, 0. Okay, we go to example 4.1. Find the equation of the circle with center 2, 3 and radius of 5 units. So recall back just now we have this general formula for a circle, right? Okay, we have center and we have the center 2, negative 3 and radius 5. Okay, so from these two information here, we can determine that A equals to 2, B equals to
-3.
R equals to
5.
So when you sum in all these values into the general equation of the circle, we will get 5 squared equals to x minus 2 squared plus y minus -3 squared. We extend all these terms out. 5 squared equals to 25. X squared minus 4x plus 4 plus y squared plus 6y plus 9. So you will obtain y squared plus x squared plus y squared minus 4x plus 6y equals, minus 12 equals to 0. And this is the general equation for the circle having radius 5 and center 2, -3. Moving on to example 5.2, find the center and radius of the circle which has the equation x squared plus y squared plus 4x minus 6y minus 23 equals to 0. Okay, just now we work out that we have center and radius and we find the equation, right? So given the equation, we want to find the center and the radius. So you must be able to also find in the other way. Not only you work out the equation. Okay? So we have this equation here. So how do we obtain the center and radius of the circle? So just now we know that x squared plus y squared we know that x minus a squared plus y minus b squared equals to r squared, right? So this is the general equation of the circle. So from here, we have to group the x and y together first. X belongs to x, y belongs to y. So we have this thing. Okay, so after that, after we group all the x and y together, now we can do completing the square. So how do we do completing the square? Do you remember when you learned this in Form 4? So x squared plus 4x plus something squared minus something squared. Okay? So what is this thing here? Coefficient of b divided by 2. The coefficient is 4. So 4 divided by 2 you get 2. 2. Okay? Then for y also, y squared minus 6y plus something squared minus something squared. So negative 6 divided by 2 is negative 3. Negative 3. Okay, let me write off this thing first. Okay, and copy down the negative 23 equals to 0. So next thing, we simplify this term and this term together. So this term becomes something squared. So we take the coefficient and we take this thing and this thing. So x plus 2 plus, so 2 squared equals to 4 plus also something squared, y and negative 3. And having a square here, and we evaluate negative 3 squared equals to 9 minus 23 equals to 0. Okay? Now, next thing, we move all the constant to the other side. So, copying down the square term, 3 squared equals to 23 plus 9 is 32 plus 4, 36. So, we have this equation. So, what square equals to 36?
6.
So, we have equals to 6 squared. So from this equation, now we can determine the center is, okay, you see, you compare with the general equation. This is negative and this is positive. So these two are not in the same symbol. So how do we get it into the same symbol? We change this thing into x minus negative 2 squared. Okay? And here we compare. This is negative, this is negative. Same, right? So we remain this one. So now we can determine the center, which is negative 2, 3, and the radius equals to 6 units. And that's all to find the center and radius. Okay, moving on to example 5.3. Find the equation of the circle which passes through the point A 1, 8, B negative 6, 1, and C negative 2, negative 1. So, very important things you have to know here. You have to always remember the general equation of the circle. Having x squared, x minus a squared, plus y minus b squared equals to r squared. Always remember this general equation of the circle when you want to attempt the question under the subtopic for circle. Okay, so we know that the circle has these three coordinates, a 1, 8, b negative 6, 1, and c negative 2, negative 1. So what we can do here is we substitute all the values, not all the values, we substitute each coordinate into each general equation for the circle. So if we sub a1 8 into this first equation, into one the equation, then we can obtain equation 1 as 1 minus a squared plus x minus b squared equals to r squared. Substitute b negative 6, 1 into general equation, we will get this thing, and substitute c, we will get this thing. So if you can observe from these three equations, right, these three equations will equate to the same constant. which is r squared, meaning that the left part of this equation is equal to the left part of this equation equals to the left part of this equation. So these three equations are actually equals to each other. So now we want to find the value of a and b first. So how do we find the value of a and b? We can do simultaneous equation. We equate any two equations. Let's say we take equation 1 and equation 2, taking, because this is r squared, this is r squared. So these two are equals. Straight away, you take the left part equals to the left part for equation 1 and equation 2. So after you simplify, you obtain the equation a plus b equals to 2. We name it as equation 4 for later on use. Next one, with equate equation 2 and equation 3, we will obtain the simplified equation 2a minus b equals to negative n. Label it as equation 5. Now, solving equation 4 and equation 5, you use the simultaneous equation method that you have learned in Form 3. This one you learned already in Form 3. So, you will obtain a equals to negative 2 and b equals to 4. Okay. Now we already find the value of a and b. So what are we short of? We are short of the r, because now we want to find the equation, right? So to solve for r, you just take the value of a equals to negative 2 and b equals to 4, substitute into any equation 1, 2 or 3, any one that will do. And when you substitute in, you obtain that r squared equals to 25. Means r equals to, the radius is 5. So putting back all the a, b and b and r into the general equation, but you don't change the value of x and y, you just remain it as x and y, because x and y is the main component for the general equation of the circle. So you will obtain x squared plus y squared plus 4x minus xy minus 5 equals to 0. Okay. So this is about circle. Does anyone have any question about circles?
No.
So since you don't have question, now I have a question for you all. So who can tell me the general equation for the circle?
X minus a squared plus y minus b squared equal to r squared.
Okay, very good. So you will claim your gift after this. So we have here x minus a squared plus y minus b squared equals to r squared. Do you remember for this equation what we can obtain what information? The first one is
Radius.
radius. Radius is
R.
r. The second information is
The point.
what points?
X and Y coordinates.
That is not the information we can get.
The center.
Yes, the center. So the center is
A and B.
not a and b, coordinate a, b. Okay? Because a represents the x coordinate and b represents the y coordinate. So this is all for circle. Circle is quite easy. So remember to score in your exam. Now, moving on, we have subtopic 5.3 ellipses. So under ellipses, you have to learn equation of ellipse and also sketch ellipse of different major axes. Okay, just now circle very easy. Circle, all the distance is the same from the point to the center, right? You just only have to sketch one like this. But ellipse, you have different type of shape depending on its major axis. Later on, we will discuss what is major axis. So, ellipse is defined as an ellipse is a set of points in a plane such that the sum of its distance from two fixed points is a constant. The two fixed points are called foci. So, we have this point foci f1 and this point focus f2. Foci is verb and foci is plural, focus is singular. So f1 and f2. So you take one point like this one p1. So this p1 to f1 plus p1 to f2 is actually also equals to f1 to p2 plus f2 to p2. Okay? Since f1 p1 equals to f1 p2 equals to 8 unit, this 2 is 8 unit lah. We use number for an easy representation. Then f2 p1 and f2 p2 is 4 units. So this f1 p1 plus f2 p2, f2 p1 equals to f1 p2 plus f2 p2. Okay? And what are they equals to? They are equals to 12 units, and this 12 is known as the constant number. So now we go and discuss the major axis of an ellipse. So ellipse can be drawn in two types, where major axis being vertical or horizontal. So what is meant by major axis? Observe from this thing. So this thing is like horizontal, right? So the major axis has to separate the ellipse into half, and this is called the major axis. Okay, whereas this ellipse is standing and having the major axis vertical. Okay, so since we have major axis, we're also going to have minor axis. This minor axis is perpendicular to major axis. For example, just now we know that this is the major axis, right? The line perpendicular to the major axis and also can separate the ellipse symmetrically is this line, and this line is called minor axis. Same story in this ellipse. Okay, observe from the two ellipses, the point of the intersection of the two lines in each ellipse is called the center. So each ellipse have an intersection of point of the two lines, right? And the point is called center. The ellipse is symmetrical about both major and minor axis. Okay, so now we already discussed and defined what is ellipse. Now we are going to solve for the general equation of an ellipse. Okay, to find the equation of an ellipse, consider the case where the center of the ellipse is at origin. We consider the easy part first. So this will be the center. This will be the 2 point for side. And F1 having coordinate negative C0. F2 having coordinate C0. Let's take this point on the ellipse as an example. I don't put the ellipse curve here because to make you to see the points, the lines and the points can easily. So you have P, X, Y here. So let P be any point on the ellipse. Using the definition of an ellipse, we know that these two lines, when they plus together, they will equals to a constant number for an complete ellipse. Okay, so since they have the complete ellipse, now we let the constant number be 2a. Okay, so substitute in the formula for the distance, you put in all the required coordinates. So the first point is from the foci to point P. You let P be x1, y1. You let foci 1 be x2, y2. So x plus c squared plus y minus c 0. You square it plus with d2. D2 is f2c0 and p xy. Let p be x1, y1. F2 be x2, y2. So when you substitute in x minus c squared plus y minus 0 squared equals to 2a. So rearranging this equation, you will obtain this third one, and squaring both sides, you will obtain x plus c squared plus y squared equals to 4a squared minus 4a squared. Okay, and you have it here. Then you simplify all the terms together. Then you will obtain this one, and finally you cancel off the term which has the same one. So you obtain this one. Dividing this equation by 4a will give you this simplified equation, square root x minus c squared plus y squared equals to a minus c over a x. After that, squaring both sides, you will get this equation until you do here. So when you reach this point, the 1 minus c squared over a squared, you can view it as a squared minus c squared over a squared. Okay? So when you divide each term by a squared minus c squared, you will cancel off this term. So you will get only x squared over a squared. Whereas y squared divided by a squared minus c squared, you get this term. On the right side of the equation, a squared minus c squared divide each other, you will get only 1. So you let b squared equals to a squared minus c squared, and finally we can obtain x squared over a squared plus y squared over b squared equals to 1. So this is the general equation for an ellipse with center 0, 0. Okay? So after we determine the equation, we can also determine all the intercept. So remember from just now the ellipse equation, let's take the major axis and the minor axis as the x and y axis. So when this ellipse intersects the axis, we will definitely obtain intercept, right? So to find the y-intercept, we let x equals to 0. So we will get y equals to plus minus p. Whereas to find the x-intercept, we let y equals 0. We get x equals to plus minus a. So the intercept of the major axis are called the vertices of the ellipse. Hence, the vertices of an ellipse with general equation x squared over a squared plus y squared over b squared equals to 1 is plus a minus a, 0. Okay, this is the view for an ellipse. We have the equation x squared over a squared plus y squared over b squared equals to 1. So these 2 points is called the vertex because this is the intercept of the ellipse with the axis where on the major axis. Okay? So having these 2 points here is called the foci. And since we have the foci already, the line passing through the foci and perpendicular to this major axis is known as lattice rectum. Lattice rectum will give you the length 2b squared over a squared. Okay, so until here, do you have any other problem?
Yes, sir. I want to ask, how did we know from the equation, right? How did we know the major axis and minor axis from the equation?
Okay, so very good question. So we will continue on how to determine whether the major axis is horizontal or vertical. So just now we view only horizontal line. So now let's all review the vertical first before we go into determining. So please stay put with me. So in the vertical major axis, the equation of the ellipse with major axis vertical, center 0, 0 and foci 0 plus minus c is given by equation y squared over a squared plus x squared over b squared equals to 1. Okay. Observe from here that just now our equation for my major axis is this one, right? Okay. A squared is under y squared. Whereas from just now horizontal major axis, our a squared is under x squared. And one point you have to know that is a is always greater than b. A is always greater than b. Okay? So which number that is bigger, that is under x or y, will determine which one is the major which the position of the major axis to be vertical or horizontal. So let's see here. If x squared is bigger, then a squared is under x. So means that they will give you an ellipse of major axis which is horizontal. Whereas this one, a squared which is bigger than b squared, the number is under y squared. And from this equation we can know that the major axis is vertical. Okay, so this is the standard form of the equation having center 0, 0. So review the first one first. The major axis which is horizontal, having the equation x squared plus over a squared plus y squared over b squared equals to 1, where c squared equals to a squared minus b squared and a bigger than b. So center 0, 0, foci plus minus c and 0, vertices plus minus a, 0. The same thing for vertical major axis, just that these all points will become the y coordinate and the x coordinate becomes 0. Then the equation having y squared over a squared plus x squared over b squared equals to 1. So the number the x or y having the bigger number under here will determine the position of the major axis. So do I answer your question?
Yes.
Okay, very well. So we will continue on with center at HK. So this is very easy. You learned that the transition of a curve, right? Okay, let's view it. Let's view this sketching. you have y equals to x. The line y equals to x. Now, when you let x equals to minus 1, this will make your equation to move to the right 1 unit. So you will obtain this curve. Okay? This is called the translation of a straight line curve or any other curve as well. So when you put negative 1 to x here, then this graph will move to the right by 1 unit. Same as here. If you put negative h here, this means that your curve will move to the x coordinate to the right side by h unit. Okay? So, give you another example. This is y equals to x squared. So, when you let y minus 1 and y plus 1 equals to x squared, you will obtain this thing. This is 1. Okay? So, this curve is moving up by 1 unit when you plus 1 to y. So, this also makes the same thing. When you minus k to y, it will move y down by k units. Okay? So, this is only shifting the curve. This does not mean that you alter the shape of the ellipse. The ellipse will still have the same foci value. We still have the same vertices, not same foci, the same major axis length, the same minor axis length. Just that you move the position of the curve into having center HK as compared to just now, you having center 0, 0. Okay? So now we review some example. Find the equation of the ellipse with the following foci and vertices. Okay? So foci at 4, 2 plus square root 2 plus minus square root 5, and vertices at 4, 5, 4, negative 1. So since x value for both vertices is constant, this ellipse has major axis vertical. Okay, you see here, these three having x value as constant, right? 4 only. So this foci has major axis vertical. So by inspection, this ellipse has center at 4, 2. Because give you the point of foci 4 and 2. And you can obtain a equals to 3, b equals to plus minus 2, c equals to negative square root 5. And this equation have x minus 4 squared over 2 plus y minus 2 squared over 9 equals to 1. So for part B also the same thing. Example 5.6. Show that the following equation represent ellipses and find their center, foci and vertices. So just now we have the foci, we have the vertices to find the equation, right? So now we have to find the foci or vertices from the equation. Continue on with example 5.6. Show that the following equation represent ellipses and find the center, foci and vertices. So first one we have equation 16x squared 4y squared minus 64x minus 40y plus 100 equals to 0. Okay, so this is also the same method as just now from the circle, right? Okay, first thing, we group all the x together. So 16x squared minus 64x plus 4y squared minus 40y plus 100 equals to 0. Okay, remember in completing the square, you have to make sure the coefficient of x squared always be 1. So how do you make sure the coefficient always be 1? You factorize out the coefficient. This coefficient has 16. So you take out 16 and you remain x squared minus 64 divided by 16, you will get 4x plus factor out the 4, you will get y squared minus 10y plus 100 equals to 0. Now continue on to do the same completing the square. So 16x squared will give you x minus 2 squared minus 4 plus 4 y minus 5 squared minus 25 plus 100 equals to 0. Okay, now next thing, you multiply in the factor you just now, the number you factor out just now. So you will get 16x minus 2 squared minus 64 plus 4y minus 5 squared minus 100 equals plus 100 equals to 0. This 100 and 100 cancel off becomes 0. You're only left with negative 64. Bring the negative 64 to here. Other side. Become positive 64. Okay. Is this the general equation for an ellipse?
No.
No. Why? Because there is no fraction. So how do we get the fraction? We divide each term by the constant here, 64. So when 16 is divided by 64, you will get 1 over 4. When 4 divided by 64, you will get 1 over 60. So is this the general equation for an ellipse?
Yes.
Okay. So from here we can determine the center. The center is
2, 5.
5. Okay. And we can determine also the value of A, B, C. So A is bigger or smaller than B?
Smaller. Bigger.
Bigger. Wait, A is always bigger than B. So A will take the value 16. B will take the value 4. Okay? So from here we can know that A equals to plus minus 4, B equals to plus minus 2. C squared equals to A squared minus B squared. You will get 16 minus 4, C equals to square root 12. Plus minus, don't forget. Okay? So from here we can obtain the cosine B. Since this is a magic axis at y, so x is a constant. 5 plus minus square root 12. Okay? Then the vertices as plus minus 0 plus minus 4. Okay, and that's all for today. So after that, please go back and do the question B. You try out, and if you have any question, we will discuss in the next lesson. And go back home to remember to open your textbook to page 276 and do all the checkpoints over there. This is your homework for today, and I will see you in the next class. In next class, we will discuss back about in the next class we will discuss back about parabola and hyperbola. Okay? So thank you, class. Class is dismissed.